Hi, welcome to another lesson at EDU Solutions Institute. Now, today we're looking at the CSEC physics syllabus. Now, last lesson we looked at calculations using motion graphs to explain motion of objects as well as to calculate the unknown from our motion graphs, so speed time graph or distance time graph. Now, this week we're going to actually start with the formulas of motion and how we can use these formulas to calculate unknown quantities relating to motion. So stay tuned as we explore on our motion equations. Now, motion equations are very unique, are very helpful for quantifying motion. So not all objects will be able to easily sketch a motion graph for. But once we have some unique properties of objects moving, we'll be able to answer any unknown question about motion. So here we have some various equations that we use for motion. Now, notice that we have some symbol forms. So the first thing we need to know is, what do these symbols represent, right? And then we're going to look at, when do we use these formulas? Now, let's go. So we see the first one here says that speed. Now, speed, even though some books will have some symbols to represent speed, we like to keep speed as just speed, no symbols attached. So speed is equal to s over t, just like v equals s over t. So therefore that tells us that s is a symbol that we're going to use to not represent speed, but it will be used to represent distance or displacement. In some books you will have it as x. Then t, universally, common t represents time. Time would be in seconds, distance or displacement is in meters. Alright, so these two formulas or equations, notice they are the only ones unique, except for the last one as well. And we use these two formulas only under one condition. And that condition is if the object is moving at a constant speed. So once the object is moving at a constant speed or velocity, this would be the formula to use. Alright, so we never use these two formulas if the object is accelerating. And accelerating from our previous lessons would mean that the speed is changing or the velocity is changing. So once the object is moving at a constant speed, that means if it's going at 5 meters per second, it's always at 5 meters per second. Then we use these two formulas. Now, let's go to the next. And what's unique to that, we have A, and A represents acceleration. And acceleration is measured in meters per second squared. Alright, then we have V. Notice this V is the same V here. We're going to quantify and say this V represents final velocity. But in this formula, final velocity would be the same as initial velocity because it doesn't change. Right? The U represents initial velocity. Both have units of meters per second. Right? And we know time already is t. So in this formula, we see that acceleration is equal to the change in velocity over time. So in some books, you'll have a delta v over t. And the delta here means change. Because the velocity is initially at this value, then it's going to be finally at this value. So there is a change in velocity. Right? Now the second one after is making v the subject of this formula, which we get v is equal to u plus at. Right? So therefore, this is if we're finding the final velocity. After it has accelerated, what would be the final velocity at a specific time period? Then our second equation here is, again, represents distance or displacement is equal to ut plus half at squared. And we have v squared equal u squared plus 2as, as well as finally s equals u plus v over 2 times t. Now, what you notice here, except for the last one, that all these formulas have something unique, and that is they all have a in their formulas. So what that tells us is that we only use this when the object is moving with an acceleration. So therefore, once it's changing speed, then we have to consider one of these formulas. If it is not changing speed, then we focus on the top two. So therefore, it's very easy to remember that once we go with a constant speed, we focus on the first two. Once we're accelerating, the object is changing speed, either it's going faster or it's slowing down, then we look at these formulas. So if an object is slowing down, we say that it has a negative acceleration. And therefore, if it is speeding up, then the object will have a positive acceleration. And that will be very important for the a values that we use if it is primarily slowing down. If it's a negative, it will change the value than if you just put it as a positive number. Alright, so acceleration here, the a represents both speeding up and slowing down. Alright, now when do we use these formulas? Or which formula to use under which situation? Now, I always like to go with these steps. The first step is to identify what we're given using symbols. So once we use our symbols, we know what we're given, right? Once we know what we're given and what we need to find, then the next step is use formula that have all symbols with the unknown as well. And what that means is, let's say we have v being 5, we have u being 3, and we have t being 2 seconds. And the question wants us to find a. Notice we only have VUTA. So that means we don't have any S, right? So if we don't have S, we cannot use this formula or this formula or this formula. So therefore, we only can focus on finding A by using this, which is the same as this one, right? But let's say we had A, which is 1 meters per second squared. We don't have time, and we're asked to find the distance. Therefore, we have these three, we don't have S. So we look at what we have and what we don't have, right? So if we don't have time, which is a very important one, that means we can't use this or that or that or that. Because all of these have time in it, right? But these two has S and T in it, but those two are unknown. So therefore, the only one we can use is this, because we have V, U, A, and we don't have S. So what we realize here is that it doesn't have to be the one that is the subject of the formula to identify which one we use. We identify which one we use based on what we're given and what we need to find. So therefore, if we need to find S, we cannot use this formula because it has no S in it. Alright? So therefore, that's the unique thing that you'll always remember once you need to know which formula to use. So next lesson, we're going to actually look at using these formulas in different situations in calculating unknown quantities based on different question structures. Alright, so that's it for us today. Please remember to like, share, and subscribe to the channel so you can learn more about the CSEC physics syllabus or any other syllabus that we are doing. So take care, and I'll see you next week where we continue to learn more about our CSEC physics syllabus.